force of the wind hitting it.
You said, okay, there's a beam right here.
There's a column right here. Support beam.
Support, okay.
Yeah.
And it goes down. I wonder what's underhead.
It goes down to the garage.
Oh, okay. Okay, no, I'm curious.
In the garage, they have those pilaster beams across. That's where this is resting. That's where that's resting. That's where that corner right there is resting.
But again, on the outside of this portion, you don't have much of a lateral resistance.
No,
in this direction. Yeah.
Okay.
That's what I'm saying. This is the first one is the best one too.
But this is only the
it's only
column tie into that roof and
that's right.
That. So I agree with you. This can shift. And that's why you get so much water involved in this area.
Oh gosh, yeah, that poor thing. That's been taken a.
And then not only this, the creation of this forcing that you say is moving, we have a same scenario upstairs, and that's what's causing basically all this.
Yeah, and also if you notice that
a crack. Yep. That's the force.
Yeah, that's force.
That's force. That's only but force.
And pushing that way can pop this open.
What about what a support on that side? For a future engineer of America. But there's no support thing over here, or how does that?
There's some. I don't mean that there's no support.
Okay.
But when they initially designed, they supposed to have this into consideration as a structure as a whole. Yeah. But under this extreme condition, this 120 miles of wind or 110 miles wind, when it blows in and in this corner, and that part is maybe over there is more rigid, and this part is more flexible, and in the middle is another kind of different rigidity. So there's a movement, and there's going to be a little differential movement. Okay. And along the interface, there's a lot of time they're going to tear up and open up and crash. The chances are that's why probably why we have some tiles cracked over here.
So, but as far as for fixing this stuff, we just fixed the deck, right? It's nothing like the whole thing's not falling down, really.
No, it's just because of certain deformation caused by the horizontal wind load.
So what's the problem out here?
They're just what they're going through. Oh no, actually, what the problem is, see where the tarp is? That's not for decoration. The reason we know, and the reason is that we put through that up is we after the storm it leaked down in that pillar down in the pool room. And what is it? Then it re-leaked again. Every time it rains, keeps wanting to re-leak there. So, again, and the first time I know we noticed it is, and maybe we'll have to ask Bonnie specifically if she didn't, notice it. When we can dig out pictures too. I want to dig out pictures on that pillar specifically because if it did leak before, and we didn't notice it, then that's a different story. But if it did, or if it was...
You wouldn't have noticed it because if it did rain, and if it did leak, you'd probably get less than a pint of water at the most. Okay. You won't notice it. You will notice it when you get a massive rain or a hurricane or something like that. That's when you're going to notice. Now, you wait till we get another big storm like this, you're going to have the same problems all over again. Yeah. Because the problem hasn't gotten fixed yet. Okay. You see, you give me 180 miles an hour wind, just 80 miles an hour wind this way with gushing rain, you're gonna have the same scenario.
So what we'll probably do then is when we do go to fix it, we're gonna make it. How do we make sure that it doesn't happen again? Well, a different kind of flooring, a different seal, or
there's really just like Tan said. I mean, the structure of the house is. You got to have two types of support: this support and this support.
Yeah, vertical and lateral, right?
They have to tie in.
Or horizontal and yeah.
And they're tying in. For example, they're tying in over there on that beam. It goes. This beam right here goes to the structure of the wall over there, and that's probably with another pilaster beam. And same thing over here. They tie in, but you still have a void. That's what he's talking about. There's still an opening. This is still an opening. Okay. The only thing that can protect it is run a big wall right here.
Oh. Yeah, like a shear wall.
Yeah, a shear wall.
But then you have to make sure it transfer down.
Yeah.
Yeah.
Oh, okay. So,
Okay.
but well, basically.
Yeah.
Over here, you notice that also separation.
Yeah. It's bloated.
Yeah, it's because of movement.
Mm-hmm. That is definitely because of when you have it straight and this. And like he said, you know, over there the house is more solid because maybe because of the brick veneer. Here, it's an open game.
Mm-hmm.
And even inside, it's quite open.
Oh, yeah?
Yeah.
Well, that's the worst part. The center of the house is the one that does this crap.
Yeah.
Well, then it sounds like to me though. But we're as long as we've got the what you were saying, the mother, where you talk about the mother, he was talking about the boards up there. What are they called again?
The fire screens, the beams.
The ones that were up.
Call it the motherboard.
The motherboards, yeah. Yeah, you said as long as those ones are okay, then we can. And that to me makes sense though, because again, it doesn't seem cosmetic or like this. Buildings are made to do that so they can still stand. That they'll survive the storm.
When we design some structure, we check the stress of the member itself. If it's overstressed, you're going to have a structural failure.
Oh.
The second criteria we check is the diffraction or the drift. The drift is horizontal movement.
Okay.
Okay. And that we need to check that, and rigidity of the components.
Okay.
So if they have a differential rigidity, you have something weaker here and strong here, and anything in between, they can have a little differential movement. Yeah, but in order not to crack, today's way design, we try to limit that movement to the minimum amount. For instance, like you have a sheetrock. Okay, you want to crack the sheetrock. The member is more like if you have a 360 inches. If you have a 1 inch diffraction, you will crack more than 1 inch.
Okay.
So in that kind of ratio. So obviously, when wind blows and the gust, whatever.
Yeah, and it hits.
In certain action under the window, it exceeds that.
Okay. No, and that makes
limit.
That makes sense, and but then when you see the cracks, because you were even telling me when you guys were hammering in up there, we were probably going to get. Some cracks.
Cracks on the sheetrock.
Yeah, cracks on the on the sheetrock in there. If you guys want to, do we want to go?
But it doesn't mean it's not structurally
sound. Yeah. Okay. Yeah. That's the one I want to make sure. But if you got a crack, I imagine the crack in the motherboard, then you got to be scared. But yeah, he had explained to me, and in fact, you could even see when they were redoing the barrels. You could, in this little corner, you could see daylight.
What we did here, we took the roof out, completely out, all the plywood, everything out. Then we did a sloping on the pattern. We did it with a 2x4s, just make it slant. Then we laid the plywood with insulation. Then we laid the plywood, and then we did the roof cover. But when we took all that.